So for example, maybe I'll motivate it through some simple example. So let's say you are modeling the happiness of a person, and you are trying to, let's say there is someone who has just 100 rupees in his pocket, and you give 10 rupees to him. So he will be somewhat happier, right? And there is another person who is having 1 lakh rupee with him. You give 10 rupees to him. He will also be slightly happier. So who will be more happier? The one who has 100 rupees. If you are giving the same increment to both of them, right? You are giving a plus 10 increment to both of them, but the one with the lesser money is more happier than the one with the higher money. So a curve like this will model that. So let's say someone has this is x equal to 10, and you are looking at the happiness as a function of money. So when he has 10 rupees right now, let's say he has 100 rupees right now. He is happy to some extent. Now I am giving, let's say 10 rupees. So now he became 110, like I added plus 10, okay. I gave plus 10 rupees. So how much did his happiness increase? This much, right? This is increase in happiness. Right? So for a plus 10 increment in the money, his happiness increased by this much. Now let's say you look at this point. Let's say he has 1 lakh or 10,000, 1 lakh rupees. Now I am just increasing his money to the same plus 10 I am applying. I am just applying plus 10. So now his happiness is not decreasing, it's kind of constant, okay, or maybe it's slightly increasing, okay. So this increment is what? Or maybe I should just plot it slightly better. Okay. Now, what is the increment in this guy? Not even this much, right? This is the increment which is less than the first increment. Then you call such a function as a concave function. Because if you draw a line in this, the line is below the curve. Correct? So it's a concave function. So this understanding will give you a mathematical way to verify whether a function is concave or not. Right? So what are we saying? If you look at the slope here, that is, slope is the rate of increase in happiness, right? Because if you give 10 increment in x, how much is my happiness increasing? That is the slope. If you look at the slope here and look at the slope here, the first slope is high compared to the second slope. So that means the slope of the function should be a decreasing function. Okay. So the slope of the function should be a decreasing function. As x increases, f dash of x should decrease. Right? Here f dash of x at 100, f dash of 100 is higher than f dash of 1 lakh. So that means the slope is a decreasing function. So how do you understand whether the slope is a decreasing function or increasing function?
Second derivative.
Look at the second derivative. If the second derivative is negative, then slope is a decreasing function. Right? If the second derivative is negative, then slope is a decreasing function. That is exactly the way that we will verify whether something is a concave function or not. Okay. So you look at the second derivative, if they are differentiable, of course, even this function is concave, but it's not a differentiable function, because this is also the slope is decreasing, but this is not a concave function. Like this is not a differentiable function. Double derivative is not possible. But whenever there is a double derivative possible, if a function is differentiable twice, then if the double derivative is negative, that is the slope should be a decreasing function, then you call it a concave function. If the double derivative is positive, then it's a convex function. So for example, if you look at this, initially the slope is negative and the slope became 0, then it became positive. That means the slope is increasing function, right? Because the slope was initially negative, then it became positive. That means the slope is an increasing function. That means the double derivative is an increasing function, like positive. Double derivative is positive. So if slope is decreasing function, implies concave. This is same as f double dash of x is negative. Similarly, f double dash x of is greater than 0 implies convex. Okay, so this is how you can verify whether a function is a convex function or a concave function.